chapter number 3. So let's take some doubts, but before going to the doubt, let's start with the back exercise question. I'll take some 10 to 15 questions. That is, total questions in your NCERT book are only 18. Okay, all the questions are very easy, very important, and most of the above, they're the same on the concept we have studied. Either it is Nernst equation or electrochemical cell or how to get yeast cell. Okay, very easy and very important also. So we will have your doubt session. Okay, let's begin. So the first question we have in your NCERT exercise is, we need to arrange the metal in order in which they displace each other from the solution of their salts. We have been provided aluminium, copper, and then is iron, magnesium, and zinc. And the question is asked that we need to arrange them that they can displace each other from the solution. That means it is a kind of displacement reaction. This is something which we also have studied in our 10th class. Okay, but now we have done electrochemistry, so we can arrange them on the basis of electrochemical series. Now, you have studied now that topic, electrochemical series. On the basis of reduction potential and oxidation potential, we can easily arrange them like right, this kind of. So we can easily arrange them on the order of their reactivity. So we need to check out that which compound or which metal is more reactive than the other one. So according to electrochemical series, the answer would be Fe, copper. That's all. That means magnesium is more reactive than aluminium, than zinc, than iron, than copper. Okay, this is very simple, very basic question. Now let's move to our second question. The question number 2 is, we have been provided the potassium equals to minus 2.39 volt and silver positive equals to 0.80 volt, and we have also mercury of reducing power. We have been given the 4 example: potassium, silver, mercury, and magnesium, and we have to arrange them on the order of reducing power. Now, Bacha, you know very well, we have studied this concept according to Nernst equation application, that if there is higher oxidation potential, that means higher its tendency to get oxidized, or we can say their reducing strength is also high, है ना? Or reducing agent power is also high. So we can arrange them on the order of the power. We can see that silver is something which is least, then mercury, magnesium, and then potassium. We can easily arrange them. Mercury is 0.80, then mercury is 0. I have done something wrong. Okay, I think there should be magnesium than mercury, because magnesium value is lesser than mercury. Okay, so silver. Then now let's move to some higher question, which are a little bit tricky, and we can let's see an example that we have been given. there is a cell potential of galvanic cell in which the reaction has been taking place, like chromium plus copper 2 positive.
Ma'am, where is the
We have
krypton?
Sorry,
Ma'am, you have not write
would
the
you please
series.
repeat the question? I have not written the
Krypton.
part. That's very easy. Okay. Now let's move to our next question. The third question is, we have been provided, we have to calculate the standard cell potential, chromium plus cadmium 2 positive, that is converting into chromium 3 positive plus cadmium. And there is provided cadmium 2 positive, that is minus 0.404 volt. The point here is, bache, when you have been provided with the reduction potential values of two half cells, we can easily calculate the E node cell. We know the formula that for calculating E node cell, we need to calculate both our E node reduction as well as E node oxidation. Or we can say E node cell is something which is equals to E node right minus E node left. Now, as we can see, chromium is something which is converting to 3 positive plus 3 electrons. That means there is oxidation taking place. On the very other hand, the cadmium is something which is accepting the electron. So on the basis of this, can we easily calculate the E node right and E node left? Definitely yes. On the basis of reduction and oxidation, we can put the value of E node cell. That is E node right, which is equals to minus 0.40 minus 0.74. Why? Because chromium is releasing electrons and cadmium is accepting the electrons. Oxidation reduction. So we would get the value that is almost equal to 1.14 volt. Now the point is, we have to calculate the delta G node. Delta G, that is gives free energy, that is equals to minus NF E node cell. We have been provided with E node E cell. We have been provided with Faraday, that is 96500. Now the point is, what do we need to write about the N value? See, bache, we have been put chromium with chromium 3 positive and cadmium 2 positive with cadmium. That means reaction do not have the same number of electrons with it. Chromium is concept of calculating the Gibbs energy, that is delta G naught equals to minus NF E naught. Okay, now we have done the concept how we can calculate the delta G naught. We have done the question. Let's move to our next question, that is the question is, we have to write the Nernst equation and EMF of the following cells. For example, we have been provided with SN2 positive, which is converting to 0.50. The value is given. And there is H positive, 0.20. And finally, H2. Okay. Now we have been provided a reaction in which two half cells are present over there. We have to write the Nernst equation for this so that we can calculate the E node cell value. Now, but if you know that the E cell equals to E node cell minus It's 2.303 RT divided by NF. We can write it 0.0591 divided by N log. We can write the product divided by reactant. So H positive divided by SN2 positive. Now, this question we have already done, that whenever we take the reaction, we just take the final product. Moreover, we take the final product as which one is showing into the ionic form, because in electrochemistry, the main role is of ions. We have done this question before also. Whenever we have taken the example with solid state, whenever we're taking with the solid state or something, what's happening over here? They are not conducting any ions, due to which there is no much any kind of electricity. Okay, same as it is in this particular question, we are having the only ions, that is hydrogen and T. Okay, so this is the reaction we have completed. Just a second. Sn is converting to Sn2 positive plus 2 electron, and H positive is getting the electron to become H2. Okay, I'm sorry for that. The reaction is, the nernst equation is wrong, because we have to write the oxidation upper and the lower is reduction. Moreover, the number is getting into the power. Okay, now we have done the complete the nernst equation. We have E cell, E naught cell minus 0.0591, N is equals to 2. Because we have completed it, we can easily calculate E naught cell. If the value of these two have been given, the value of the concentration has been given, we can calculate the E cell. All right, so this was all about this question. Now just see one or two questions. I just want to say the question are very easy, bache, and all have been done. So I just do not want to take much time on this. Let's take any kind of question, a very simple question. Okay, the question is conductivity of 0.20 molar solution of potassium chloride at 298 Simon per centimeter inverse, and we have to calculate the molar conductivity. So first of all, for calculating the molar conductivity, we have to calculate the lambda m equals to kappa into 1000 divided by concentration. That means we have to calculate the equivalent conductivity as well as the molar conductivity and the concentration. If we have all these values, then we can calculate our lambda m. Let's check out. The question is, divided by concentration, that is given in molarity. We have been provided with the conductivity that is equals to 0.0248. Kappa is given equals to 0.248, and the concentration is given by 0.20 molarity. Since we can easily express our concentration either in molarity, so we just take and put the value over here. Okay, now we can calculate by solving the equation, and we can get the molar conductivity. Okay, let's see a few examples. The question number 3.17, we have been given that we have to predict whether the reaction is feasible or not. For example, we have been provided with Fe3 positive and I negative. Now the point here is, bache, you know already, whenever we need to calculate the feasibility of reaction, we just calculate the E naught cell value. And if this value comes to be positive, that means reaction is feasible. If it's not comes to be, if it's coming in the negative form, that means reaction is not feasible. Reaction is not taking place. Okay. For example, we have been provided with this question, and all the value of iron as well as iodine is given. Fe3 positive and I negative. Okay. 3 positive plus I negative. Now, first of all, for making the reaction complete, we need to know whether reduction is taking place on which compound and oxidation is taking place at which compound. Iron 3 positive is converting to iron 2 positive, that means it's accepting an electron. And I negative is converting to I2, that means reduction, oxidation. We will calculate the E cell value, E naught right minus E naught left, E naught, and we will easily calculate how to check out the feasibility. If the value comes to be positive, that means reaction is feasible. Okay. So class, I just wanted to say to you that we have done our chapter number 3rd, and back exercise questions are also the same. If you have any kind of doubt or query in this chapter in electrochemistry or in the back exercise, then please let me know. We will start with that particular question. Okay. Yes, class, any doubt or query, please let me know. Anyone, just raise your hand if there is any kind of doubt. The first unit test is of chemistry also. So I just, anyone, if there is kind of doubt or query, please let me know. Okay, one more point, bache, as in yesterday's class, as I'm, yes, Vidhi. Okay, one more point, as I can see, I think there is no doubt or query in chemistry. Yes, bache. Hello.